Okay, well, my name's Scott Morris. I'm the water quality coordinator for the Sauk-Suiattle Indian Tribe. We're a small tribe of maybe 310 members up in the northwest corner of Washington State, near the town of Darrington. And Knotweed has been our invasive species of choice. Although bullfrogs on one of our lakes, I am interested in that. We've got two males we're trying to kill on one lake. Thankfully, no females so far. We hope. Anyway, let's see. Oh, I've got to advance it. It's not advancing. There we go. So this is our watershed. The tribe is near the confluence of the Sauk and Suiattle River, which is the Sauk is the largest tributary of the Skagit River, which is the largest river in Puget Sound. And we have all 5 species of salmon, as well as steelhead and all the salmonids you would expect in a major river in the Pacific Northwest. And the first infestation of knotweed was found near the North Fork Sauk River, where it meets the South Fork, about 40 miles upstream, down near the bottom of this map. And at least the first infestations in the floodplain, I should say. There probably were upland infestations like in the town of Darrington and even along the Skagit historically. Anecdotally, you hear people talk about as kids playing in the bamboo. But the Nature Conservancy and Forest Service found this infestation way upstream on the Sauk back in 2002, and tried to figure out what are we going to do about it. So the Bedell, this is the 40 miles upstream on the Sauk, and the Sauk runs south to north, so it's we're down south of Darrington here. And the town, it's not a town, but like a neighborhood called Bedell is probably where the first infestation started there. In 2002, it was about 20 patches. There were 11 in the neighborhood itself, kind of an inholding and Forest Service land. And then there were about 9 patches they found in the floodplain. And then it's all Forest Service land around there. So the Forest Service had to do an environmental assessment, and it took them a few years to do so. And unfortunately, the flood of record on the Sauk happened in 2003. And if you know anything about the way knotweed spreads, it is by the roots and even bits of plant it floods rip out the plants or the root wads, and they reestablish downstream. So even as small as like a half-inch fragments can reestablish. And so it's a very persistent plant, and you can't mow it or burn it. It really requires herbicide translocating to these root wads that are really persistent in the soil. So unfortunately, in the time it took them to do the environmental assessment to decide what herbicide would be safe to use on Forest Service land, we had this flood of record and another big flood in 2006. And by the time that the EA was approved, it was up to 208 patches, as you see there in 2006. So in just a few short years, knotweed can really explode. And so getting on it early, of course, is important. Since then, a dedicated partnership was established called the Skagit Coordinated Weed Management Area Working Group. And it's multi-agency, Forest Service, state agencies, Skagit Fisheries Enhancement Group, Skagit County, a number of us working together for many years now, and divvying up the watershed and as it makes sense to hire crews and go downstream and work on this stuff. So let's see. So this is the tier system that we've set up. We're still in that map. The part of the map I was showing there was down or upstream of Darrington, south of Darrington, that Bedell stretch. is still an eradication zone because we've got it pretty low numbers there. The red areas indicate more of a management zone where it's unlikely to be able to eradicate it. But we do have it at manageable levels in most of the Sauk River, and we've been able to move farther downstream on the Skagit. But if you don't do a top-down approach, the problem with knotweed is it's just going to you can't work too far downstream knowing there are upstream patches that are just going to repopulate. So you really need to set up a top-down approach. So this is what it looks like in 2024. And the main thing to take from this map, the orange dots are all dead patches. So this is sort of the success, and those are only the dead patches we found in the last 3 years. Otherwise, this map would have a ton of orange patches from the past 2 decades. But the green and the blue show patches that were either brand new, the green, or the blue were older patches that resprouted that we hadn't fully killed yet. And typically when they resprouted, they're smaller and easier to eradicate, but it takes a few years. So what you see is we've got a lot of success on the Sauk, which is the Bedell up to Rockport, where it says Sauk-Skagit confluence. And then the Skagit River moves east-west. And from Rockport downstream, we've made steady progress in the past 6 years. Mostly we focused on the Sauk and the upper Skagit, which is not really shown on this map. We have other partners who work on the upper Skagit. But because we were able to get the Sauk to manageable levels, we were able to use additional funding and able to work more efficiently and move downstream. So what you see here is the green patches are new patches, and that's because it's a more recent effort. And in the first few years since 2018, you see a lot of the orange patches from Rockport down to, say, the Baker River section there, meaning that we've made a lot of progress in there and we have less and less resurgence. But you have all these newer patches in downstream stretches that we've opened up. So within this overall picture, I wanted to zoom in on the area that says the Sauk-Skagit confluence, the lower 4 miles of the Sauk River, to show how even hopelessly large patches can be brought under control with persistent efforts. So this is that lower 4 miles of the Sauk where it meets the Skagit. And in 2013, this is a map from 2013, unfortunately with different colors on the patches, but the color scheme essentially is anything that is in red here were dead and old patches. But the blue and the yellow are either brand new patches or old ones that were persistent. So there are well over 100 patches in 2013 of this lower 4 miles that we started to fear we were losing control of this area. And a lot of it is where that arrow is pointing. There was a cut bank on the Sauk and 2 creeks that were feeding, it was like a knotweed incubator. It just kept feeding knotweed downstream into this whole area. And we didn't have total land ownership. We didn't have permission from the landowners at that time. Although right about 2013, we started to get landowner permission. And our crews found a 4-acre patch right here of really old growth knotweed that because of the creek feeding it into the river and the river cutting on the bank, it was really causing us problems. Once we got access to this, we started to strategize how to hit it, and unfortunately some leftover animation. So this is what those patches look like. In 2012, when we found them, our WCC crew, Washington Conservation Corps crew, found, and you can see the crew down in that lower right photo, the lower 2 photos. This is well over their heads. It's 10 foot tall. This was a patch that we didn't know about, but we didn't know how extensive it was until we were able to get landowner access and realize it just chokes out every kind of native plant, which is why, from a salmon perspective, we would rather see, obviously, cedars, conifers, things that are going to be stabilizing the bank and creating salmon habitat over time and shade, obviously. So we strategized how to deal with this. And in 2013, we returned with two 6-person WCC crews, a 200-gallon water tank to mix on site, to mix the herbicide on site, and a backpack rodeo. Essentially, we used backpack sprayers and just a rotating, people rotated in and out, mixing new. We bent canes to get on certain pathways to get access safely without having drip on our personnel. And then they went at it, and also had to dodge hornets, as you see in that lower right corner. But this is the before photo in 2013 in May, before it was even fully grown, but getting there. Obviously, it's 10, 12 feet tall. This is the after picture in 2014, because later in 2013 is when the crews did this. You see a slight bit of resurgence there down in that lower right corner, but a really effective kill rate. And we were eventually able to plant trees in this area, but we had to kind of wait to make sure we had killed most of the knotweed. And then policeman's helmet came in after it, and we had to deal with that as well. So nowadays in 2014, this whole section of the river looks a lot different. And all the orange patches are the old dead ones. And the green and blue are the ones that we had to spray again. And as you see in 2024, it was about 22 patches. We've got it down between 13 and 40 in the last few years, instead of well over 100. So it's not hopeless, but it's just such a persistent plant that you have to keep going. So you'll see the section lines that we have here. This, I think, is an important way for us to measure progress. When you're covering 70 to 80 river miles on 2 different rivers throughout the floodplain, one of the problems we encountered in measuring progress for the granting agencies, including BIA, by the way, we use multiple grants for this effort and multiple partners, obviously. But one of the problems in demonstrating the progress we're making is you have success in the upstream reaches, and so then you move downstream. And so your graph that showed a lot of nice downward trends of herbicide use and downward trends of knotweed patches all of a sudden jump up after 3 or 5 years when you move farther downstream. And so if you're just doing one graph for the whole survey area, the granting agencies are like, you're backsliding, and it's like, no, we've made amazing progress upstream, and now we're able to go downstream. So we divided them into sections so that you can set up a spreadsheet that looks like this, and you can divide it by the upstream river sections, 1 through 6. We've got steady progress, and then the downstream sections are going to have some pretty large herbicide mix. You see we've used a lot of herbicide, but that comes down over time, and you can see in the downstream reaches we use a lot less herbicide. The other aspect of what we do is there's a fair amount of upland patches, particularly in towns on the river like Darrington. They're not as mobile, but more the human vector is what brings them into the floodplain and causes us problems. So we've realized we need to get a hold of, there's also this is a logging town, so there's a lot of logging equipment, and when people just sort of mow it over with their tractor, and then where do they dump it? That's where the knotweed ends up, and oftentimes, over the edge of the bank and into the floodplain. So we've realized we need to work with landowners, and we've made steady progress. You can see in town, we're down in the few dozen patches, and people seem to appreciate it too, because you can see how big it is in their yards, and now it's down to hand sprayers in a lot of these places where we used to have overhead high patches, because people just keep mowing it or burning it, and it doesn't work. So one last thing I wanted to show is a new method we're pretty excited about. And if any of you work with really big patches of knotweed, you know that it really slows you down, because the traditional methods involve a pretty thorough coverage on the leaves to make sure you translocate as much herbicide down to the roots as possible. But there's something called the drizzle method that one of our contractors pointed out to us that works really well on blackberries, where you have a really large blackberry patch and you need to work more efficiently. So you use a different nozzle with a faster flow rate, higher herbicide concentrations, but you move much quicker, and you kind of wave the wand instead of worrying about leaf coverage. The way it works is it's a more direct jet that then splatters on the leaves and drips, and you get a very similar coverage, but moving much faster. And you end up with the similar amount of herbicide applied if you do the math right. It's important to look at application rates, how the nozzle works. So we've done some trial methods or some trial spots to see how it worked, and we're hoping that when we go back, starting in May, when we see the knotweed growth ramping up, that we're hopeful to see a good enough kill rate to start using this. And where this would be most effective is downstream on the Skagit, where we have these old growth patches of knotweed. Our crews can cover a lot more ground with the same sort of efficiency we've had in the past. And this could be a real game changer on the seemingly hopeless patches like we showed you earlier. If you can move through that much more quickly, it could really be a game changer on places that seem hopeless. And I guess that's the main message, is it's maybe not as hopeless as it feels. So that's the summary here. Multi-agency partnerships include as many people who have skin in the game and who have the expertise. Top down is crucial with knotweed. Don't leapfrog or jump downstream to a really big patch until you've got the upstream reaches under control. Jump on it as early as you can. If you find it upstream, hit that stuff early. Don't get discouraged. Large patches can be brought under control, but think in the long term, it's a eternal vigilance is kind of the mantra. So that's everything I've got for you. I can't see the chat right now, but I'll do the stop share and maybe that'll help. But these are all our partnering agencies over the years.